The Air We Breathe, a clean air topic by Miles Wong at De Anza College. Upon research, I found that there was no shared definition of what clean air is, but one way I could describe it is on my commute to work via bicycle, I would pedal through certain areas, and right when the scenery changed, the air quality would be different. From a canyon through a rock quarry, pedaling behind large trucks to the next city, and then traveling on an avenue, the air quality would be different, making me breathe different. Short breaths behind trucks from the quarry, and long breaths during a more isolated clean air outdoor mile. The Clean Air Act has been established in 1970 and revised in 1990. A federal law designed to protect human health and the effects of air pollution. The four major threats to the environment are acid rain, urban air pollution, toxic air emissions, and stratospheric ozone depletion. This Clean Air Act has helped cut ground level ozone, a dangerous component of smog, by more than 25% since 1980, reduce mercury emissions by 45% since 1990, reduce the main pollutants that contribute to acid rain, sulfur dioxide and nitrogen dioxide, by 71% and 46%, respectively, since 1980. And it also has phased out the production of use of chemicals that contribute to the hole in the ozone layer, and reduced the lead content in gasoline, which has cut lead air pollution by 92% since 1980. Acid rain was something that the act deemed as a threat, and it's any form of rain, snow, fog, hail, or dust that is acidic. Most acids that mix in with those form are sulfur dioxide and nitrogen oxide. When those two mixed are released in the air by point sources such as electricity plants where they burn fossil fuels, which are 2/3 of sulfur dioxide and 1/4 of nitrogen dioxide, coming from manufactories and oil refineries. They mix with water before falling to the ground. Here's an example of the pathway of acid rain. Starting with the number 1, you can see that the emissions of SO2 and NOx are released in the air from these factories and smokes and cars releasing smog or NO2, NOx. And then they travel by wind and air currents to the clouds or the precipitation, in which they then mix and combust into acid particles, at which then come down on Earth, which may cause harmful effects on the soils, forests, streams, and lakes. The stratospheric ozone, if you're standing on Earth, it is the second layer above the troposphere level. The stratospheric ozone is made up of O3 at the atmospheric level. It is a sunblock layer that protects us from harmful ultraviolet rays. At the troposphere level, ozone forms by chemical reactions between oxides and volatile organic compounds. The pollutants come from most human activities such as driving cars, power plants, industrial boilers, refineries, chemical plants that chemically react in the presence of sunlight. Some effects of the ozone layer depletion to human health could be skin cancer, cataracts causing the lens of your eye to be cloudy. It can affect plants by stunting their growth and their developmental process. And it can affect marine ecosystems by the amount of UVB that occurs at the euphoric zone is vital because too much can affect the foundation of the aquatic food web, which is phytoplankton. So too much solar radiation can affect phytoplankton by resulting in reduced survival rates. And increase also in the UVB also could affect the population reduction of other marine organisms such as fish, shrimp, crab, and other amphibians. Aclima is a company that wants to make the world a better place by using environmental intelligence. Their CEO, Davida Herzl, describes the company as a company that maps global pollution at human scale measure and analyzing air pollution and greenhouse gases by block. Our platforms help government, communities, and businesses reduce emissions and work together to improve public and planetary health. I'm also a driver for this company, and I would describe it as I collect hyperlocal emissions around Santa Clara County at high quality geographical scale. With the data, we could give it to places like the Bay Area Quality District, the Bay Area Air Quality District, in which they can implement rules and regulations on air quality. Some of the things that my car measures are nitric oxide, nitrogen dioxide, ozone, methane, black carbon, fine particle matter. So all of those things that I just mentioned, we collect, and during the shelter in place, they noticed that all of those things have been decreased, and they connected it to less traffic, or as the traffic goes down and the less of a commute, there are notable decreases. But for the ozone, as nitrogen dioxide levels trigger the increase in the ozone. This increase is called the weekend effect by atmospheric scientists. They see levels of the ozone rise during the weekend when there's less of a commute. Here's a graph of a decline from February 6th to March 19th, which is including when people started working at home to closing schools, both private and public, and the shelter in place of nitrogen dioxide. And nitrogen dioxide is a gaseous pollutant that is formed from fossil fuel combustion, and it is a key component of smog. NO2 can be emitted from unvented gas appliances. NO2 irritates the respiratory system and can lead to coughing and wheezing, increased asthma attacks, and reduced lung function. Here's another graph of carbon dioxide. It's the primary greenhouse gas resulting from fossil fuel combustion. It doesn't affect us humans when outdoors. The primary health concern is its role in climate change. The main source of CO2 is transportation, electricity, and production, and industry. Another company that is trying to make the environment a better place is a Canadian-based clean energy company focusing on direct air capture that captures carbon directly. Carbon Engineering's direct air capture technology removes dioxide directly from the atmosphere. They have two main uses. One is permanently storing the captured carbon deep underground to create negative emissions and utilizing captured atmospheric carbon to produce clean synthetic transportation fuels.